Good morning, everyone. Welcome to week 6 of the course. We have only one more week to go next week. So we are almost there. And today we are going to continue talking about pandas, get a bit more advanced with analysis. So I would say it's a bit more interesting than last week. Last week there are a lot of random details that we need to know in order to be comfortable working with pandas. So it's not, in my own opinion, the most exciting topic of the course. But this week we are solving an actual problem. So things get again more exciting. Yeah, so the poll is open. You can add your comments, and when you are adding your comments, I can show you an overview of the feedback you kindly provided us during the midterm evaluation. So generally, I'm happy to see that most of the comments are positive, and most things seem to have worked well. About the pace, most of you were happy. A few of you said that it's a bit slow, and that's understandable because some of you had a bit of background in programming, so it might feel a bit slow at the beginning, especially. The lesson content, generally, you found them useful. Again, some of you found it too simple, which is understandable if you have already had some experience in programming. Exercises were mostly balanced and sometimes challenging in a good way, which is the aim. Most helpful aspects, in your opinion, were the hands-on coding during the lessons, practical exercises, clear lesson materials, and supportive teaching and help sessions, which is, again, great to hear. Least helpful aspects, repetition of basics for experienced students. Yeah, we always try to find the balance because we have a diverse range of students coming from geography, coming from geology. We even have students from other departments and even faculties. So we are always trying to find the balance. Yeah, about usefulness, lesson materials, well, everything was generally positive, and I'm very happy to see that auto-grading has worked rather well. I know that for some people it hasn't worked perfectly, but we will improve it for next year, and some of you have provided us with good feedback already, so we will work on that, but generally it seems to be working and supporting you with your studies. Yeah, so I'm happy to hear that things are working well. We will collect feedback again at the end of the course, and this will help us make the course better. But let's take a look at your comments. So some of you seem to have liked pandas, and that's great because we are going to use it a lot today, next week, and if you continue using Python for data analysis, there is probably you will continue working with pandas. So it's good that you enjoy working with it, and for some of you it probably was difficult. It's a lot of information, so you will get used to it. I'm sure it won't be as difficult over the time, but yeah, there was a lot of information. Today it will hopefully get better because we will practice many of the things that we learned last week. Of course, they were the basics. We need them every week. And we'll learn new things, and we'll learn how to solve problems. So it will get more fun. So let's quickly look at courses web page, not GeoPython, but GeoPython. And see what is the learning goal for today. Yeah, so today we will work with pandas. We'll continue working with pandas, and we get a bit more advanced. So that's the panda part of the course, like the first part before the break probably. So we will analyze data in Python using pandas, repeat analysis workflow. So one of the things we will learn to do today is to repeat a process for different data sets, and that's a major motivation for many of us, to just make our life easier as students or professionals. That's something we will look at today. Then we will look at errors in Python. We have talked about them briefly, and of course, I'm sure every week that you're doing your exercise, you see a wide range of errors, and you probably manage to solve them. So today we look a bit more closer. We took a closer look into errors in Python, how to decipher them, and how to fix them. And we will talk a bit more about debugging. Yeah, so that's what we're going to do today. Let's go to Noppe. I have already pulled the latest changes, so we are working with lesson 6, the L6 directory. So we will continue working with a data set that is similar to what we had last week. And as I said, we used to work with a different data set for years. And then last year, the summer was a bit different. So David and I came to the conclusion that it's a good time to update the data. And it was mainly because of an article that we saw on Yle last summer, end of last summer. When was it? In September. So apparently, Finland broke its all-time record number of hot days. And I guess they had defined hot days as 25 degrees. So overall, if you look at the whole country, the number of hot days were more than ever before. So it was like, at least by the time this article was published, was 66 times. So that was the major motivation for updating the data. So we got some fresh data from FMI, and that's what we are working with today. For last week, we had changed the data a bit to a format that supports our learning. But today we are going to go with the original data from FMI. So if you decide to do anything related to this, if you get a data set from there, it will look pretty much like what we are doing today. So the data is already downloaded. We have data from, so the article is about Finland in general. So they have counted the whole country. We are not going to do that here, but we are going to test if we broke the records in Helsinki alone. Did we have days, 66 days with temperature hotter than 25 in Helsinki? So that's what we are going to test, and we are going to repeat it for a number of cities. So as you can see in the data folder, we have the same data available from a number of stations from around the country. So we will repeat the process for those. So that's what we are going to do today. There is a bit of instruction on how to get data from FMI. They have a very good portal for downloading data. So if you're looking for data to just practice pandas or for your thesis or some work, this can be a good source. But for those of us who are students at University of Helsinki or in Finland, you have access to Noppe and the data is already downloaded. So I will skip this part, but just remember that they have a very good portal for downloading data, and that's where we got the data from. So I chose air temperature and then the period for which you want the data. So we got the data from 1st of June to end of August, and the new format you want, and the cities or the stations from which you want the data. And these are the files we ended up with. They are CSV files, each for a separate file for each of the cities that we will be working with, or each of the stations. So a little bit about the data. We can take a quick look at one of our data sets. I opened the Helsinki data. So we have the station name, we have the year, month, day. They're in different columns, unlike what we had last week. And then we also have time at which the temperature was recorded. And we have some information about temperature and the relative humidity and the gust speed average. So this is what we have in our data. And the column names are quite self-explanatory, so I don't think I have to open it up, but there's more information here. So, yeah, so to give you a bit of motivation about what we are doing today, I will give you an example from what we are actually doing in this course behind the scenes with the course assistants. So what we are going to learn today, we do a number of things, but the main thing we are learning today is grouping data in pandas. And that's a very useful analysis, well, depending on what you're doing, but you will most likely end up using grouping in your work in future. So what is the idea behind grouping? So we have now temperature collected from different days, and each day we have many recordings. So we want to group the temperatures for the day. So we have one temperature reading for the day. So that's the idea. So I will give you one example from what we do with the course assistant. So we have an Excel sheet with all your names. So we have all your names in an Excel sheet with which I have shared with the course assistants. Of course, we have your names. And we have some information about your grades every week, and then later on we will have your grade from the final assignment, which will be, by the way, published next week, so I will talk more about it. So this is the Excel sheet we have. It is an Excel, but it could have been also a CSV file. And then I have another column here called CA, or course assistant. As you know, we have 3 course assistants working this year. So we have Emilia, Inka, and Evi. So what I do, I have assigned each person to one of the assistants. So it's either Emilia, Evi, or Inka. And this repeats because there is like 70, 80 students in this course, and this has repeated. So I need to have some group level information about assistants. So what I have done, because this repeats, so like Inka is grading, for example, 20 of you, Emilia is grading 20 of you, so and I wanted to calculate a number of things. How many do each of the assistants, how many students are they grading? Because I wanted to balance the workload. So if there's 80 students, I want every assistant to grade 20-something, so it will be balanced. I also want to see how they grade you. I want it to be a bit systematic, not that someone is super strict, the other one is a bit kinder toward grading. So I want it to be systematic. So what I check, so I group all the rows of my data based on who grades them. So I end up with something like, okay, Inka has graded 22 students, and on average, she has given a grade of, I don't know, 4.3 to the students. So this is grouping. So you have many columns, many rows in your data, and there's a column that is the key for grouping. So you use that information, for example, here, the initials of the course assistants, to do the grouping, and then for each group, you can calculate the count, statistics, whatever you need. So this is what we are going to do today. So that's the idea behind grouping. Does it make sense? Yeah, so this is a very simple thing that we do in Excel or whatever environment you have used previously for studying or analyzing spreadsheets, and now we learn how to do it in Python using pandas. So that was a bit of introduction. Let's just get started. I'm going to start my work with the data from Helsinki, but remember that we always start by importing the libraries we need. It's a good practice to always import your libraries at the very beginning of your script. So it can happen later on in your work when you're doing your final assignment, that at the beginning you import pandas because you remember you need pandas, but in the middle you remember, oh, I wanted to import also matplotlib. Then you start importing it in the middle, and that's not a good practice. It works, but remember, so import everything at the very beginning of your script. So I'm going to import pandas. Next thing I'm going to do is importing my data. As we already saw, it's under the data folder. It's called Helsinki_kumpula.csv. Let's just run the cell. Next thing I'm doing, so I defined the path to my data. Now I'm providing this path to the read CSV function that imports the data. You remember it from last week. And in data that we get from FMI, the null values are marked as dash, so it's just a hyphen. So this is what I know from looking at the data, and also if you read their website, they say that, okay, if there's a missing value, it's just marked with a dash. So I'm going to specify that so Pandas knows how to handle the missing values. Okay, so now the data should be imported. So there's a small information box here for handling different kinds of missing values. And the reason why we have this is that we used to have a different data set in this course last year's, and it was like this. So the missing values were marked with different numbers of asterisks in that other data we had. So sometimes if it was a one-digit variable, one-digit number, it was just one asterisk. If it was 3 digits, it was 3. If it was 5, it was 5. So what I want to remind you here is that if you have different ways of assigning, like if your data handles null values in different ways, you can also provide a list. So if it is inconsistent, if sometimes it's dash or sometimes it's a star, you can also provide a list of null values. And we have it here, so you remember that can be also the case, and you might also need it in your exercise. Yeah, but in our case it was simple, it's just a dash, And the data is quite clean. Usually when you get in real life, when you get data from somewhere, it's full of missing values or mistakes. But this data is quite clean. So okay, so now that we imported data, let's take a quick look at our data using .head method. So I'm going to use .head, data.head. And this is what the data looks like. It seems that the importing works nicely, so I don't have a problem there. I want to also look at my columns in the data. Of course, I can just view it up there, but as a reminder how to access the columns. So data.columns, here I can see a list of the columns that are in my data. Okay, so our lesson today is, in our lesson today we are concentrating only on temperature, but the data also has information about the wind speed and the humidity, so we are going to get rid of those. And for that, we are going to import a fresh copy of the data without those columns. But just to show you how to delete a column, something we didn't do last week, this is how you would delete a column from Python. So there's a method called drop. Then from data, I'm going to drop some columns. And for that, you can pass in the list of columns that you want to remove. So you can remove several columns at the same time. So it can be a list with as many items as you need. So there are some columns I don't need. I'm going to copy them so I don't have any typos. I don't want to keep this relative humidity, so I copy the full name. I also want to get rid of the other column, this gust speed. So I will also copy that name. Remember to put them in quotation mark. And that's it. That's how you drop columns from your data. So you can go ahead and try it with .head to see if the columns have disappeared. They should have disappeared now. So this is how you can drop columns. For example, if mistakenly you have calculated something or added a column and you don't want to re-import your data. But of course, if you have a big data, instead of importing the full data and then dropping the columns, you can just import the columns you need. So that's what we're going to do now. But this is how you drop data. So one thing that is important here is that there is a parameter you can pass into this function called inPlace. So you can pass in a function parameter called inPlace, which is by default false. So here I didn't provide any false. So what does it do? It means that it will overwrite the original data if it's set to true. So in this case, it's not changing my data at all. That's why I'm storing it in a new variable. This could have been a different variable. I could have named it data2, then my original data would have been untouched. But I want to just overwrite it manually. So when you do this without saying anything about inPlace, it will not affect this at all. It will create a new data frame, then you can store it in a new variable, like in this case. But one thing, if you want to skip this part, then you can just set inPlace true, then it will just overwrite the original data. So you can just write this without storing it in a variable. So the result is the same, but just remember that you can do it in both ways. So yeah, so that was one way of getting rid of the columns that I don't want, but as a better practice, it's better to just start with whatever you need, not import the whole data set. So that's why we are going to do something that seems redundant, but it's a good practice. I'm going to import my data, but this time I list all the columns that I actually need. So I didn't include the wind, the speed, and humidity here. You remember this from last week, use calls. So let's just run this. The code is already typed in. We also have data.head to look at our data. So you can see now we have a fresh copy of our data without the columns that we don't need. Okay, so now this was not new. We know how to do that. Now let's rename columns, and that is something that you often need, especially when you are working with columns like this. Like, this is not a good column name. It's super long. Like, if you want to, you just have to copy paste it. And also, it's not a good idea to have spaces there. So you can do different kinds of things and with column names, and this can be a bit problematic. So I would go with something without the spaces, and definitely not this long. So I'm going to rename some of the columns to something that I'm more comfortable with. So let's look at the columns again to remember what we have, and then we use the values to rename some of them. So for renaming columns, we use a new data structure in data type in Python that we have not seen before, in this course at least, and that's called a dictionary. Dictionary is very useful. It's not obviously only for this. You can use it for many things. But in this course, we use it for renaming only. Yeah, so what is a dictionary? Dictionary is a type of data structure in Python for storing key value pairs. So what we are, it's very different to list, but it's still a collection data, so it has some similarities. So in a list, you don't have key values. Of course, you have the index values that serve as the key. So index 5 is attached to a certain item. But in a dictionary, you have keys. So I can have a dictionary of student names with their grade. So whenever I type in the name of the student, so it doesn't have to be a number, it can be a name, it can be a string, I get the grade of the student. So dictionaries are very useful, and now we are going to work with them a bit. Yeah, so I want to use dictionaries to rename some of my columns. So I have a column called observation station, which I don't like. I want to rename it to station with all capital and no spaces. I have this column time, local time. I'm going to rename it to just time. And air temperature mean, I will rename it to temp. So this is what I'm going to do. And let's start by creating the dictionary. So this is how you create a dictionary in general. And now we are going to use this dictionary later for renaming. So as I said, in a dictionary, you have key. So in this case, the key is the old name of the variable. So I'm just going to copy it from here to make sure I won't have any typos. So this is the key of the dictionary. And then the value of the dictionary item here is the new name. So I'm just going to name it station. So then I'm going to add a new item to my dictionary. So in a dictionary, you can have many items, and always remember that it's a pair. So there's a key, there's a value. So I'm going to also rename this. So I'm just going to copy the value from here. So this time, local time. And the new value for it will be just time. And there's a third column I want to also rename. I will copy the value from here. And remember to provide also the new name for it, which will simply be temp. So this is how you define a dictionary. And remember, this is the kind of bracket you will use for dictionary. So in lists, we saw in lists, we had the square brackets. When working with tuples, we had the parentheses. And with dictionaries, this is the sign, the curly braces that we use. So I will name my variable, my dictionary actually new names, to just be more clear. And I'm going to print it out to my screen to see what I just created. And you can see it's a dictionary. So we created our dictionary. You can see it's defined as a dictionary. You see the sign. And you have a key, you have a value. So you use the key to access the column, and then you update it with the new value that you have defined. Now that we have a new data type, let's also do what we usually do. I'm going to test the type of the dictionary or variable. So it was called new names. And you can see it's a dictionary, so dict for short. So a new data type that we haven't worked with, but it's very useful for many things. Okay, so now we haven't renamed anything. We just created a dictionary that provides pandas with the information it needs for the renaming. So this is how actually we do the renaming part. So I'm going to store it under a new variable, which is actually the same variable, so I'm going to just overwrite my data. And this is how you do the renaming. So data.rename, and what it takes as the input is the dictionary that we created. So we pass it to a parameter called columns. And the dictionary we created was called new names. So of course, it was neater. We had a longer dictionary. We just defined it up here and we used it. Of course, you can just do it on the go. You can just put the dictionary right here without storing it in a variable. But it's more neat this way. And then I'm going to print the columns to see what happens. So yeah, so now you can see that the column names are updated. They're not those long names anymore. So the renaming worked successfully. Okay, so now that we learned how to rename columns in pandas, let's do a little practice. So the temperature values in our data files are in degrees Celsius. As you might guess, we will soon convert these temperatures into degrees Fahrenheit, something that we have done a lot in this course. In order to avoid confusion with the columns, so that we don't end up with two temperature columns and we won't know which one is which, let's rename the column temp to temp_C. So do this now. I will wait for a couple of minutes, then I will show how I will do it. Yeah, so let's rename our column temp to temp_C and rewrite your original data. how many of you managed to do this. Just raise your hand. Okay, most of you did it, so I will start doing it as well. So I will start by defining the dictionary that I will be using for the renaming. Again, I will call it new names. You might have called it different things, which doesn't matter. So temp is going to be renamed to temp_C. So that's my dictionary. This is the part that I actually do the renaming. Sometimes I've seen the students forgetting to do this. They just create the dictionary and forget to apply it. So remember that you have to also apply it using using rename method. And you just pass in the dictionary that you just created, new names. And then I have data.head to look at my data. So yeah, it works fine. Now I have a new column, or the column was renamed to temp_C. Soon I'm going to start analyzing my data now that I've imported the data. I'm happy with the column names. So before doing that, it's a good practice to explore my data a bit. So I will look at some of the properties, things we learned last week. So I will look at data.shape, because so far we haven't looked at how big our data actually is. So let's look at that. So we have over 2,200 rows in our data. So it's a rather large data set. It's from only 3 months of summer, but we have 2,200 rows because we have many observations per day. And we have 6 columns in our data, which we had seen before. Let's also look at the head of the data. It looks fine. I would also look at the tail of my data. That also looks fine. So it gives me an idea about the data, and it seems that everything is all right. It's also good practice to check what kind of data types we are working with before we start our analysis. So I'm going to use data.dtypes, which we saw last week, to check what kinds of values I have in my data set. So you can see we have mostly integers and also a float, which is the temperature. If you're interested, you can also look at the description of your data, the descriptive statistics, and we remember that we can just simply do that with data.describe. So it gives you an idea what kind of values you're working with. So for example, the average, so the average temperature, for example, for all the readings from these 3 months has been 18.4. It gives you an understanding of what you have in your data. So now that everything seems to be in order and we know what kind of data we are dealing with, we are going to take the next step in our analysis, and that is something that is super useful, working with pandas, applying functions to our data set. So very often you have data and you want to apply some function. It's not always manually calculating something. And we have already learned how to create functions, so the trick we are going to learn now is how to apply it to our pandas data frame. So we have a function that we have seen before. It's a function that converts temperatures from Celsius to Fahrenheit, so there's nothing new here. Just defining the function, we have some comments explaining what the function does, and here the calculation happens and it returns the temperature in Fahrenheit. So nothing new here. Let's just run the cell and get the function defined. I want to make sure that my function is working fine before I apply it to my whole data. So I will just test it with some simple calculations. I will use my function, which is called Celsius to Fahrenheit. And I will test it on the freezing point of water. And it's 32, so it's a temperature that I know. So I knew that 0 degrees Celsius is like 32 degrees Fahrenheit. So it seems that my function is working fine. Okay, so now we are going to apply this to our data, but before we do that, let's still one more time look at our data. So we have the old values here, and later we can look back and see how it works. So now we have the temperature Celsius, and soon we are going to apply the function and create a new column with temperatures in Fahrenheit. So there are a number of ways how you can do this, and we are going to look at both ways. So one of them is iterating the rows. So as I will say soon, if you just want to apply a function, this may not be the best way, but you still want to look at it because it's a skill you need to have to be able to iterate through your rows in your data and change things. So let's start with that. So we can use the function one row at a time using a for loop that we have seen, and the iter rows method that comes with pandas. This will allow us to repeat a given process for each row in our data frame. So it's an inefficient approach. That's why I'm going to show you a second approach, which is more efficient. And if you're working with a very large data set, and if you have like nested loops, like a for loop within a for loop, it can easily get very slow. So you have to be careful with using it, but it's very useful, and it also gives you an understanding of how things work in pandas. So when you are using iter rows, which we will do very soon, you should remember that not only you get access to the row values, but also you get access to the index value of your rows, which is useful for certain things. Okay, so let's start doing this. This is the code is typed in, so we don't need to type anything. Just look at what we have and make sure we understand what is happening. So we are writing a for loop, and this is how you use iter rows. So you have the name of your variable in which you have stored the data frame. In our case, it's just data. So you just use data.iter rows, and that's all you need. Just remember that it returns two things. That's why I've added variables here to fetch those outputs. So I get an index value. So it goes, remember, this is a for loop. So it goes through every row in your data, and every time it returns the index value for that row and the contents of the row. So I've added two variables to catch those variables, catch those values. So the index values every time gets written here under IDX. You can put anything. This is a variable name. And the information of the row will be written to row. Again, you could name it anything, but it's common to use these names. So this is just simple. Now I'm not doing anything. I'm just going to read the value and print them. So this is what you do. I've put a break here. You don't have to put it, but I recommend you to have it there because it's a for loop. It goes through 2,200 rows of your data. If you don't put this break, your screen will be flooded with the values. So I put break here. It will break after the first loop. So it doesn't print everything. So that's why we have the break. So normally you don't do it, but now because we are printing it, I don't want to have 2,200 rows of printed values. So let's just run this. So it's a for loop, but because of break, it only worked once on the first row. So you can see the index value is 0. And this is the row information. So you get a row, and from the row, I'm accessing the column value that I want. So it's just a row. So it's essentially a pandas series. A pandas series, and we know that we can access the column values using this. There is another trick that we are not using here, and it's not very recommended, but I tend to use it a lot myself, and that is using dot. So you can access the contents of a column using dot. So instead of this, I could have put row.temp_c. It's very handy. But why it's not recommended is that, for example, if you have special characters or spaces in the column name, it doesn't work anymore. So that's why I wanted to get rid of those column names that have spaces. But that's the second way of accessing columns, columns in a row. So you can just write row dot tempc without this. But this is the more standard way. But some of you who will continue with the second course, you will see that we will use that approach as well. Yeah, so this is how it works. And we have added a break for breaking the loop. I explained that already. Now we are going to do the calculation. So I'm going to do the calculation and write it to a column. So I'm defining my column first. So remember, you do it outside your for loop. So you don't define your column here, because you remember that the for loop is repeating every time. So you don't want to create that column every time, overwrite everything you have. So you outside the for loop, I define my column, then I go through it and I update the values. So I just create the column using some default value, some random value. Then I have the iterate rows and I get the index, the row contents, temp Fahrenheit. So I'm calculating the temperature Fahrenheit for that column value. So I'm getting the temperature. I provide it to my function. It returns a value. So this is what we have done a lot last few weeks. So I end up with a converted value, which I write to my column using at method that we learned last week. So take 20 seconds, look at the code and see that it makes sense. It's everything that we have learned before. So we created an empty column. We converted the value to Fahrenheit, and we are updating the value for each row using at method. Okay, so does it make sense? Okay, good. And we are going to do this a lot in the coming weeks, so you will get used to it. It's just everything we have learned in just one new package. So we are doing the conversion here, and we are using at. So we talked about this last week. You could also use loc, but at here you are updating one value at a time. So with at it's more efficient. So that's why we are using at, but you could have also used loc if that's what you prefer. So I ran it, and it was very fast. So imagine it updated 2,200 rows, but it took less than a second. So that's why people like using pandas. It's quite efficient. So now that I did the conversion, I'm going to look at my data again using that head to see if everything went well. And it did. So I have a new column added to my data called temp_f. And in it, I have the converted temperatures. So the function was applied to my data. So that was the first way of applying a function to a data frame. As I promised earlier, there is a second way, which is easier and more efficient computationally. And that's an apply method, by using an apply, .apply method. So pandas data frames and series have a dedicated method called .apply for applying functions on columns. So this is what we are doing most of the time. And this is how you would do the same exact thing. So let's start by looking what happens before. We are not writing anything to our data yet. I'm just showing you how this works. So I'm accessing the column where I have the temperatures in Celsius. And this is how you apply a function, just .apply. So you access the column or the columns that you want to apply the function to. Then you use .apply. And then here you have to name the function that you want to use. So Celsius to Fahrenheit. So this doesn't write anything to my data yet. We will see how we can write it to our data. But it just prints out the conversion. So you can see you have the index value and the converted temperatures. So with just one line of code, you could apply a function to your data frame. So it's much shorter than iter rows. So now that the result looks logical, So now that I see it's working fine, I dare to add it to my data. So I'm going to overwrite the same column I had by using the same name. So I'm using temp_f. And then the rest is the same as what we did just now. So I'm going to apply the function to the column temp_c. You could have also just copied what we had written earlier, Celsius to Fahrenheit. So if you want to write it to a column, this is how you do it. You just specify the column to which you want to write the values. And then you just run the cell, it works. So as you can see, it's just a lot shorter. So instead of writing a for loop, iter rows and everything, I just use apply and it becomes one line of code and it's faster. So remember that you can do the same thing on the multiple columns at the same time. So instead of having just one column like we did here, you could have, if you had also mean and max columns, you could have done the conversion at the same time. And the order, if you end up using this for multiple columns, then remember that the order that you use here will be also the order in your data frame. So it affects the order of the columns. So it's not really important, but remember the order is the same order you will end up with. So write it in the order that you would like. Yep, so one thing you could have also done is that depends on how your function is defined, but with our function it would have also worked if you just pass in a data series. So if I could also just write data temp_c and pass it to my function, it would have done the calculation. But with apply, it's a more standard way of doing the application of a function that works almost everywhere. So let's get used to using apply. Now that we did the conversion, let's also look at our data again. This time I'm going to look at 10 rows from my data. And it looks fine. So the conversion was done successfully using apply. So as I already mentioned, when you are applying functions, you at least have two options. You have the iter rows that goes through rows. You have more flexibility because you're going through rows. You can read different things, do different things, different kinds of calculations. So it's very good, very useful. But if it's a simple conversion like what we just did, it's enough to just use apply, and it's less typing, it's more efficient. So you have both options, and they're both good. Is it all clear so far? If yes, we are going to continue with the second part of our lesson today, and that's the grouping. And for that, we need to prepare a couple of things. Then we do the grouping. So we are going to, I already told you what's the idea behind grouping. And now we are grouping based on days. So every day we have multiple readings from different stations. I don't want to look at them all different readings. What I want to know is that, okay, this day we had these measures. This was the maximum temperature on 6th of June, minimum, average. That's all I need. I don't want to look at every row, every observation. So I want to group my data based on a column that is linked to a certain day. So I want to have a column that says, for example, 6th of June, and then I will group all my observations from 6th of June into one. Then we'll have one day. So that's what I'm doing. So here in this example, I had the initials of the course assistants, which I used. Here, I want to create a column with a neat date format, so I can use it. Okay, this is 6th of June. That's what I'm doing. I'm preparing that column. Because if you remember, well, you can look, in our data, we don't have one column that points at a day. We have separate columns. So we have the year, which doesn't matter here because all the data is from summer 24, so it doesn't really tell us anything. But we have month and day in different columns. So I want to end up with one column that says 1st of June or 1.6, however we want to name it. And that will tell me, okay, this is the same date, I can group it. So this is the goal of this part of lesson, parsing the dates. So let's look at the columns that we have. So we have related to a date. So we have one column called months. And I'm going to take a closer look at that, the first 10 rows of it. So it's an integer with values 6 and 7 and 8, because my data is from June, July, and August. Okay, so that's good to know. I will do the same thing for my days. Okay. But this time, just to change things a bit, I will look at the tail of the data. So 10. So the last reading is from end of August, so 31st of August. So we have 31, again, integers. Let's look at the formats we have. Well, we already saw it, it's an integer, but as a good practice, let's also use dtype. So it's an integer. So this is what we are working with. Now we want to put them together. So we have 1, which is the day of the month, like 1st of June. Then we have June, which is 6. So these are two numbers, and we want to put them together. But these are integers. If you remember from first 2 weeks, we were working with strings, and we put them together. So we had like two texts, I love Python. And you can put them together, it becomes like I love Python. So we are going to do the same thing for that. And it's easier to work with it if it's string. So that's why we are going to convert them to strings. And we already saw this last week, how to do the conversions on a data frame. So I'm going to create a new column called month underscore str, so short for string. And in it, I'm going to use the values from my original month column, which is an integer. And if you remember, which hopefully you do, you can use as type method to convert your column to something else. So in this case, I'm converting it to string. So I'm going to do the same thing for my days. So I will just copy this line of code, so I don't have to type it again, but I make some changes. So I create a new column called day underscore str, or day string. And remember to also change the column, so I'm going to read the values from the column name day. And again, I convert it to string. So let's run this. So if you want, you can also look at the data now using .head to make sure this happened. This went through successfully, but I'm not going to look at that now, but instead continue with my work. So I'm going to create a new column called data. Now, data is the name of my data frame, but the new column will be called month day. Month underscore day. And for that, I'm putting two values together, the month that I converted to a string and the days. And I will apply a trick, and I will explain to you what that trick is about. column was months_str. So let's just type it in, then I will come back and explain what I'm doing. Okay, so I'm just working with my strings now. So you remember that we had like day of the month. So let's see, for example, it's 22nd of the month, and the month is July. So I want to end up with something like this. So I want to end up with this format. So I will have the month, and I will have the days with a dash in between. I'm going to use this as the key for my grouping. But what am I doing with Z-fill? So we have some days that are just one digit. Well, our months is one digit. And we have days that can be like, I don't know, eighths. So sometimes you have 2 digits, sometimes you have 1 digit. And this might look a bit messy. So to make it nicer, there is a method under Z strings. So we can apply to any string. It's not about pandas. Called zfill. So what you tell zfill does, when you say zfill2, you say that I want the output to be 2 digits. If it is 2 digits already, if it's 11, nothing is going to happen. This stays 11. But if it is 7, zfill will always put 0 behind it. So if you go with 3, it will put 2 zeros behind it. So it will make sure that you will have 3 characters by adding zeros behind it. So this makes it nice. So I will always have MMDD, even if it's 1 digit. So that's what I'm doing with string. So normally you don't need to, if you are working with just a string, you just write the string.zfill. But here, because we are working with pandas series, I'm telling Python that this is a method coming from strings. So that's why I have this added here. So you didn't have to do this, but this just looks nicer, and it's a good trick to know. So that's what we are doing here. Let's run this, then we look at the output, and it will be even more clear. I probably have some typo somewhere. Yeah, so day. It's underscore, not dash. Okay, so this is what I end up with, and this is what the zfill is doing. So 1st of June, it would have normally become 6-1, but it became 06-01, which is nicer. So I added this column, month, day. So this value in this column exactly points to a day. So that's why I can use it for this grouping that I talked about earlier. So that was the goal of what you want to do today. So, of course, we work with what we have. In our data set, we have the date the way we had. So we had different columns with years, with the year, month, and day. So I had to put them together. Sometimes you might have a different thing. If you remember last week, we were working with a data set that had the formats in something like this. We had the year, MODA. So if you want to do something like this here, then you would end up with slicing your data, your values. So now we have to put them together. So you just come up with a key value that you can use for your grouping and make sense. So I've kept this here because previously we were working with a data set that was coming in this format, and for that we had to do a slicing instead of combining values. So yeah, so we have our column ready for grouping. We have a quick thing here, which is optional, so I don't go through details. I will just briefly tell you about it, and then we take our break, then we continue with the rest, which is the actual grouping part. So we have a data type in Python called datetime. So Python can understand dates. For what we did, like now we created this column that serves our function, so it's fine. But Python doesn't know that this is actually a date. It just knows that it's a string. But you can make Python understand that this is a date. You don't need it here, but sometimes you need it. For example, if you're working with databases and you want to write date in your database, when was the record added? You want Python to understand this is a date. So we could have achieved the same thing with that. So here, it's optional, but I quickly go through it. So we had the year information, we had the date, so we had the year and the months and the date, so we make it all a string. We already did it for the months and day, so we also convert the year. So we want a full date, so Python knows this is a date. So for that, we needed also the year. Let's just run that. So we end up like something like this that has year, months, and day. So it's a full date. Now I can tell Python, using this to date time, that convert this column that has year, month, and day to a date time format. So let's just do that. And like I said, we don't need it now. We already did it a different way, but I'm just showing you. So now you see it looks different. Python put dash between the year, month, and day. So this is a sign telling you that Python now knows that this is a date time. So it's not just blindly looking at it as a string. It's a date time. So how can this help you? You can do different things. You can access the year without doing any like a slicing. It knows it's a date. So you can just access date.dt.year. It's just going to give you the years. Or you can access month. It can do different kinds of calendar calculations for you. So if dates are something that is important for you, if you're working with databases or whatever, it makes sense to define it as a date time format. Or you can get the unique number of months, which is 3. You have June, July, August. And then if you want, you can of course just write it to a new column in this format, which is similar to what we had, and it becomes, so it's essentially the same thing. So remember that Python can handle dates very nicely. So if it's something that you work with a lot, then it makes sense to use date time format. In our case, we just wanted the key for grouping. So what we did was more than enough. Okay, so now let's take a 10-minute break, and then we continue with grouping. Now everything is ready, so it should go smoothly. So we continue at 10:30. Okay, I guess we are all here, so we can continue. So remember, what was the agenda here? We want to group based on day, and we already prepared a column with the format mm-dd, and we are going to use that to group our readings of temperature for each day. So that's what we want to do, and for that in Python in pandas there is a method called group by, and that's what we're going to use for this part of our lesson. Yeah, so before we continue, let's again take a quick look at our data to see what we have. So I start by counting the number of rows in my data set. We had already seen this, but as a reminder, we have 2,208 rows in our data, and if we look at the head, this is what it looks like. So we have all the columns, and we had played with the temperatures and stuff, and we have the column that we are going to use month, day. And we also played with this date time, which also created us a similar output, but we are going to just use this one. Yeah, so our data looks good. Now let's start grouping our data. So we make our group, and when you do the grouping, you create a group object. So it's a different kind of object. I'm going to store that under the name grouped. And this is how you apply group. So it's very simple, data.group by. And as you can guess by the name, group by, you need to say group by what. So you have to provide a column name. And that's why we went through the trouble of creating that. So I'm going to use month_day for doing the grouping. So now the grouping is done. So of course we're going to explore and see how this works and do a number of calculations. But before we continue, remember that all the trouble we went through creating the month's day was kind of in vain, because you could just go with 2 column names in Python, in Pandas. So you can just say group by month's day. So even if they are in different columns, but it's a good thing to do. Of course, we learned a few things along the way, and we are more in control of how things work. So I still like our approach better, but just remember that that's not a must. You could just go with multiple columns at the same time, and that would work as nicely. So let's see, well, we did the grouping, we ran the cell, so let's see what we have type. So it's a data frame group by object. So remember, the output is not a data frame, it's a group by object, and it comes with attributes and methods that we are going to use to calculate things. So it's a special kind of object defined as part of Pandas libraries. So if you check the length of grouped, you will see it's 92. So you ended up with 92 days, and that looks correct, from 1st of June to end of July, because you grouped your 2,200 readings per day into days. So it's logical that we ended up with 92 days. And if you check the unique values you have in months, days, 92. So that's what happens. When you create a key, you will end up with as many groups as you have unique values in the key, which in our case was the number of days. So let's see what we can do with group objects. One thing we can do is to access the keys. So if you want to see what keys have been used for a group object, if you have just gotten your code from somewhere, or if you just want to remind yourself, you can just use grouped.groups.keys, and it gives you a list of the keys that are used. So these are the days. So we have 92 days from 1st of June to end of August. Okay, so what is useful is that, okay, you have these groups, now they're on a aggregate level, but now we want to access each of these groups individually and do calculations. For example, you want to see what was the temperature on 17th of July. And this is how we can do that. So you specify a day, and remember, how do you specify it in the same format as you have used in your key? So in our key, we use this month mm-dd format. So if I want to access 17th of July, I would write it this way. And how do we access a group? There's a method for that. Of course, you have to store the output in some place. I'm going to call it group 1. Then you access your grouped object, the one that you have just created, using grouping. And this is the method that you use, get group. And you provide your day or your key as the input, so you get the information for that particular group, which in our case is a day, a particular day. Okay, so this worked. Now let's see what we get as the output. So I'm going to just type in group 1. And this is what you have. So you basically have a data frame of readings for that day in July, so 17th of July. So this is a data frame. So when you do the group by, you end up with a group object that allows you to access each of those groups. And when you access each of those groups, what you get is another data frame, which is nice because you can just work on that day. So you can see we have a lot of readings from that day. If you're curious, you can also count it, but a few tens of readings. So yeah, so as I said, we can already tell that it's a data frame, but if you don't believe me, you can also check the type. So type group 1, and as I said, it's a data frame, so that's not surprising. And it's a data frame, so now you can do whatever calculation you want. So you can calculate the temperature for the day, average, minimum, maximum, anything you want to calculate, so that is nice. So now what we want to do is to calculate some mean values for the columns where we had the temperature. So we had the temperature in Celsius and Fahrenheit, and we are doing the calculations for both of them. So mean values equals group 1. So remember, we are doing this only for one of the groups, which was from 17th of July. And this is something we have seen before, calculating the average for a column or a number of columns in this case. And let's also print the mean values to the screen. Okay, so you can see that on 17th of July, on average, the temperature in Celsius was 20.94, and in Fahrenheit was 69 something. So this is how you can read values, for example, calculate the mean for a certain group. Yeah, so that is nice if you're interested in a particular day, but very often you want to automate the process. So it's not just one day you are interested in, because if you just wanted to look at 17th of July, you could have just made a selection. So probably that wasn't your ultimate goal. That's why we are going to look at how we can automate things. So for loops and grouped objects. We are going to write for loops to access different groups. So you can iterate an object, a grouped object, using a for loop, and it's going to return to you the group and the key for it. So this is a for loop that we have seen many times already. So for key and group, then I'm just printing the key and the first row in the head of the group. And I'm putting the break here, because remember, we have 92 groups here. I don't want to flood my screen with 92 times repeating this. So this only works now for the first iteration, which is 1st of June, and you get some information. So you get the head of the data. So it prints out the key, 0.06-01, that's the key, and then you get the head of the data, so the first 5 rows. So you can easily write for loops to access your groups and do whatever calculation you want. In this case, we just simply printed the head of the group. So far we have seen so from here we can see that the key contains the name of the group, which in our case was MMDD. We had created it ourselves. Let's build on this and see how we can create a data frame where we calculate the mean temperatures in Celsius and Fahrenheit. So we will repeat some of the things we have done earlier, just as a review of what we have learned today. So I'm going to create a new variable, and I'm going to call it daily data. So it's an empty data frame as a placeholder. I'm going to put values there later on. So I will just define it as a pandas data frame. So for now, it's just an empty data frame. And this D should be capital, I guess. Yeah. So what are the columns that you are interested in keeping in your, that you want to aggregate? You want to have temperature Fahrenheit and Celsius for each of the days. So remember, we are creating a new data frame of the average temperatures in Fahrenheit and Celsius based on our group data. Okay, so these are the columns we want to keep. And here is where we start writing our for loop. So I'm going to iterate over my grouped object, and remember that what you get in each iteration is the key and the group. In this case, okay, so here I'm going to calculate the mean temperatures, so mean values, so similar to what we just did. And I'm going to get it from the group, from the specified columns, which were mean columns. That's what I had named them, the temperature C and temperature F. And from that, I'm going to calculate the mean. In my data frame, I want to also add the key. So I know, okay, this is the mean temperature for the day, but what day? So I want to also add that information, so remember to do that. So to my data frame, yeah, so the information is in the key. Okay, so now what we ended up with is a line of calculations. So it's a series, not a data frame. So what I'm going to do now is to convert it into a data frame. So I have a row of values, mean, values, and I'm going to use toFrame to do the conversion. Of course, you can continue with this and see what happens, but I know what will happen, so I'm going to add one thing here, and that's .transpose. So from studying math before, you probably remember what transposing does in matrices. So when you're using this toFrame function, it writes things vertically. So you will end up with this: temperature Fahrenheit, temperature C, month, day. But you want to make it a data frame, so you want to transpose it, because we are going to write row by row. So remember, this toFrame just puts it vertically. You want to make it horizontally, so you can write row by row. So that's what this transpose does. Otherwise, you will just end up with all the values in the vertically, which is not what you want. You want to have like horizontal values as columns. So transpose converts these to this. Then in the grouping, you can go line by line and add it to your data frame. So this is what we are doing by adding this transpose here. And then what we are doing next is we are adding this row that we are calculating on each repetition into our data, daily data, the empty data frame that we created. And for that, there is a method called concat in pandas. So it's very similar to appending in lists, remember? So in pandas, if you're appending to your data frame, it's called concat. So what are you adding to your data? It's the daily data, the row. And we are going to ignore the index. So we are creating a new data frame, and we don't care about what the old index values where, so I'm going to ignore index. I'm going to set it to true. Okay, so let's take a minute to digest what we just did. There's really not much new thing here. So we did all the things separately. We had created the group, so that wasn't new. We knew how to calculate the mean values. The only thing new we did here was the transpose. We did a two-frame to do the conversion, and then we transposed it, and then concat is new, so it's just appending to the list. So nothing really special here. We just brought everything to one place, and remember to run the cell so you get the output. And now we are going to look at it, so we will see what we were trying to do. So now I printed the daily data. You could have also used the .head. And this is what we ended up with. So we created a new data frame based on the average temperatures per day. So you have 92 rows. So you did the grouping from 2,200 rows of data. You ended up with 92 data rows, and you have the calculations for each of them, which in our case was the average. So this is an example of something you may want to do using grouping. So you could have done this in other ways. You could have just written for loops and done things manually, but grouping is nice, especially if you're doing something more complicated. Okay, so that was the grouping. So we are going to now, remember, we started this whole lesson with an idea based on the Yle article. So we wanted to see if we want to see how many hot days we had in Helsinki specifically. So now we are going to test that, because now we have the daily data, so we are ready to do that. Okay, so we are going to repeat many of the things we did already, but this time for July. So I'm going to create a new data frame called July days. So I'm going to make a selection, only keeping days that are in the month July. And we already saw last week how we can make selections with pandas. And the condition here is 7. So we want the months to be equal to 7, which is month July. So it's a very simple selection. Yeah, the months wasn't all capital, only the M is capital, so let's correct that. So I made a selection from my data. I don't need all the columns. Remember, we had different columns. I'm going to make a selection, a sub-selection. So I'm going to redefine July days. And this time I'm only keeping the columns that I'm interested in, which are the temp F, temp C, and the month day, of course, which I'm going to use again as my key. So here I'm just repeating everything I did for the full data set. Now I'm going to do it only for July. So I'm going to create the groups again. And I'm going to name it grouped. But remember that this time we are only applying it to days from July. And remember that for grouping you need to provide the column which will be serving as the key. And in our case it was called month underscore day, all in capital. Let's run that. Now our group is formed. now I'm going to calculate okay, please keep on stay. Okay, so yeah, let's look at the mean values. So daily mean underscore July. And this is something we did before. You see what I'm missing here? Did you get the same error, or have I missed something? So let's see what I have done wrong here. So we have July days. For some reason I did this twice. Months 2. Okay, maybe I didn't run one of the cells. Okay, so now it should be fine. I'm going to look at the output. So daily mean July, that head. Yeah, so I did the calculation. I guess I didn't run one of the cells when I was typing. Yeah, so we looked at the sorting last week. So if you want to just sort and see quickly, for example, what is the hottest day, you can of course sort it in a descending order based on temperature and get the output. So let's do that. So for daily underscore mean underscore July, we can sort values based on a column, sort underscore values. So you can say by which column you want to do the sorting. I will do it based on column temp C. I want it to be in a descending order, so that's why I set ascending to false, because by default it will be in that order. And you want to see the hottest temperature, so I will just look at the beginning of my data using that head. Or if you want to see more, you can look at the first 10 rows. Okay, so now you can see the hottest days in the month July were 26th, 25th, 24th. So we had 22 degrees Celsius. So this gives you an overview of the hottest days in July. Yeah, so did we break the record in Helsinki? That's what we are going to try to answer next. Let's take a look at our data again. So now the code is typed in because we do not want to repeat things. We are doing the grouping again for the whole summer, so summer days. And this time, last time what we did was we worked with the temperatures, the average temperatures. Now we want to answer that question. Did we break the record? And for that we are going to look at the hottest reading of the day. So we are repeating everything we did last time with the full data, except that instead of mean, we are getting the max. So we want to get the max temperature of the day. And the rest is just the same as what we did earlier. So let's just run this. So that's what we end up with. Last time we did this, we calculated the average. Now we have the max temperature in Celsius. Okay, so in order to answer our question, remember, the question was how many days did we break the hot temperature record in Helsinki? And the hot temperature, according to that article, was over 25 degrees Celsius. So we are just writing a conditional statement and counting the number of rows. And everything is already typed in. So I'm checking, finding the rows that have a temperature, maximum temperature of 25. And I'm counting their number using len. And I'm just printing it in a F string. Let's just run that. So in the summer 2024, there were 12 days with temperatures exceeding 25 degrees Celsius in Helsinki. So remember, in whole country, there were 66 days. But in Helsinki alone, it was only 12 days. So what happened didn't happen in Helsinki alone, but overall in the country, we had those many days. Okay, so now we learned how grouping works. Now we want to repeat the analysis for other data sets. So now we have data set from Helsinki, we have from Oulu, we have from Porvoo, we have from a few cities. But do we want to repeat everything every time? Probably not. So we want to see a way how we can automate this process. And for that we are going to learn a new library, which is very useful. The library is called Globe, and I guess it comes by default in Python package. You don't have to install it separately. Yeah, so let's import Globe, and I will show you how Globe works. So Globe allows you to access files in a more automated way. So I'm going to create a list of files that I have here. So instead of repeating everything and updating the file path every time, I'm going to automate this process. So I will create a list of the files I have in my data folder using this globe function. So this globe function this globe library has a function called globe. So globe.globe. So very often in Python, we haven't seen this so much, but it's a good habit to have. When you're defining a path, especially if it's a longer path to a file, it's a good habit to have R behind. So you're telling Python it's a raw text. So it makes it less likely to make mistakes with paths, especially it's not recommended to have like spaces in the file path in Python, but this R at the beginning makes it less likely to run into error. So this is not essential here, but it's a good habit. Like I use it all the time. So R, then the path to the file. Okay, so what do I want to list? I want to list all the CSV files. So imagine you have a folder. Here it's very clean, but you might have a lot of different things. So I want to get a list of the files that are CSV. But they can be named anything because the name of the file is different. So one is from Oulu, one is from Porvoo, one is from Helsinki. So the name is different. That's why I put a wild card here. So that star is telling the globe function that it can start with anything as long as it ends with CSV. So it's going to give me all the files that are in CSV format or have the CSV extension at the end. So let's run this. And now we are going to look at the output. And everything is typed in. So let's just print the output. It's the length. So you can see, we ended up with a Python list in which we have the items. And the items are the paths to each of the files. So data, dash Helsinki Kumpula, data dash Oulu, data dash Porvoo, data dash Rovaniemi. So now I have the paths stored so I can automate my process, which is a nice thing. And you know, you have a list, so you can write a for loop. So I can just print the path to my files if I want. For loop repeats calculation for all the data. Okay, so now what you see here is a repetition of everything we have done today. Remember, I'm reading the data, I'm renaming the columns, remember what we did this morning. I'm doing the month-day thing here, using zero fill, Z fill. I'm creating that new data set, do you remember? We calculated a new data frame. So everything is repeated. I just copied everything from what we have done today, except that I put everything in a for loop. So all the code we wrote today is now inside a for loop, and I'm updating in each loop. In each iteration, I'm changing the file path. So it calculates the thing, it runs the code for Helsinki, then it runs the same code for Rovaniemi, then it moves to the next city. So this is a good example of how you can automate such processes. So instead of, so the file path is inside a for loop, so it's going to change every time. So and then it's just printing. So let's just run this and see the output. So you can see, it just quickly calculated the whole thing in less than a second for all 5 data sets. Or was it how many? 6 data sets. So you can see in summer 2024, there were 12 days in temperatures exceeding 25 in Helsinki. So in Helsinki, we had 12 days. In Lappeenranta, it was more, it was 17 days. In Oulu, we had only 5 days. In Porvoo, 0 days, so it never exceeded 25 degrees. In Rovaniemi, it was 12 days, and in Turku, it was only 2 days. So that 66 doesn't hold valid for any of these individual cities we looked at. Probably there were some hotter cities somewhere else, or as overall in the country, we always had a day with hot temperatures somewhere. Yeah, so with our test, we could not confirm what the article was saying, but if you look at all the cities in Finland, then probably you can find what they had reported. Okay, so do you have any questions from this? So this globe, you can look at it later on and see. It's very useful, but it's very simple. Okay, so let's look at the other parts. So that was the grouping, that was the main part of the lesson today. Now I'm going to talk about errors a bit. Okay, so let's look at the anatomy of the errors, and you might have figured it by now. We have been working with Python for already 5-6 weeks, so yeah, just a quick review of what we might get. Yeah, so there are a few key informations in the error that we should look for. So the error usually is, well, the main thing you will look at is the syntax error. So when I was getting the error, I just scrolled down and saw what kind of error I have. You have in this example, you have a syntax error. I can run the code and see the error. So we have a syntax error. Where is it happening? It's happening in line 4. So it tells you, okay, the problem is here. You don't have to look everywhere. Or sometimes the root of the problem might be somewhere else, but this is at least where the error is happening. And yeah, so it's happening in line 4 in cell number 1. You're working in Jupyter Lab, Jupyter Notebook, so you have cells as well. So it has some useful information about what kind of error you have and where you can find it. One thing that has been added to Python in one of a long time ago, but in one of the later versions, was that Python has become very good at providing you with tracebacks. So what you have here is a traceback. So it gives you a clue, because sometimes you have made a mistake somewhere high in your script, but it results into an error later on. So a traceback allows you to pinpoint that error. So I'm having So this is how you read a traceback. So I know I have a type error problem in this code, and the error is happening at line 5. The error is happening at line 5. But here also you have line 2. So actually the root of the problem is in the line 2. So that's how a traceback works. So sometimes you have called a function, and the reason is that here you are calling a function here. And the error is happening inside the function. So although the error is at line 5, but the root of the problem is here in the function. The error is happening here, but you're using a function that is causing the error. So that's what a traceback tells you. So that's why you might see different line numbers. So error is happening at line 5, but it goes back to line 2. You might have had a reference to there, or very often it's a function you have used, and the function has problem. So this is what we call, like, this is traceback. So this is called a traceback. It gives you traces to the error. And it is quite helpful in finding the problem. So here we have examples of different errors that you might see. Many of them we have seen already. So you might see index error if you're trying to access something in a list which is out of index. So if you have 3 items, you try to access index 5, you get index error. Name error is when you have not defined something and you try to access it. For example, in my case, I had forgotten to run a cell. Something didn't exist and I was trying to access it. Indentation error, we have been talking about this in Python. Python identifies blocks of codes based on indentation. So if you have something like this, you get an indentation error. So it's telling you that, okay, this print is not in the same line. It should be in the same line, if it is part of this. Or it should be at the beginning of the line if it's not part of it. So you should get the indentation correctly. Or with the for loop, Python expected the indentation. So that's why you get an error. Then we have type error. If you're working with, we have seen this a lot, if you're doing something between different types of data that are not compatible. So if you're multiplying a float by text, for instance, you might get type errors. So these are some of the examples of errors, and with new versions of Python, usually these error messages get even more informative and useful. Yeah, so errors are annoying, but they give you useful information about what might be wrong in your code. Another thing that you have seen in the exercises, and you might have been curious what they mean, are the assertions that you have seen in some of the exercises. You have used them in the codes. And we are going to use this a lot, like in the second part when we do the GIS, we are going to use a lot of assertions. So for example, in GIS, it's very important to be careful with coordinate systems. We don't want to do a calculation when the 2 layers are in different coordinate systems. So very often we write an assertion to make sure that they are compatible, then we do the calculation. So what is assertion? It's basically, well, sometimes you do something, it results in an error. That's easy. So you have made a mistake, it causes an error. Sometimes it doesn't cause an error, it's just wrong. Like I do a special join in GIS between 2 layers that are in different coordinate systems. The special join will work. It doesn't care, it just does the job. But it's wrong because one of them is in different, they are in different coordinate systems. So in this case, it's useful to have the assertion because the code doesn't break necessarily. So how do you write an assertion? Yep, this is an example of something that can be wrong. For example, you're doing a calculation based on kilometers per hour, but somewhere you have made a mistake, or the user has provided a value in meters per second. So this doesn't break the code, but the output is wrong. So what do? You create an assertion, and this is how you write an assertion. So you assert that the speed is greater than 0. So you're controlling the input. So you're making sure that the person, if you're working with the speed of wind and you don't want to accept negative values, it doesn't make sense in your case, you want to make sure the user doesn't provide a negative value. Because if they do, the calculation will work. You won't get an error. But with assertion, you get an error. So Yeah, so let's test this with a minus temperature. Because I've added an assertion here, and this is how you write assertion. Assert, then you have a condition, then you can add a message here, and you will see that soon. So because the user has provided minus 27 as the input, the assertion has broken the code. So it's telling you that, okay, something is wrong. You should be careful with the input. You can also add a message. So when you create the assertion like this, you can put a comma and write something. So when the code breaks, you also get that message printed out. So it says wind speed values must be positive or 0. So this is the same message you have provided up here. So whoever is using your code knows that, okay, I should provide a value that is positive. And sometimes in your code, you might have multiple assertions. You might test different things. So you want to make sure something is a float, but also it's positive. So you might write multiple assertions. That doesn't have to be one. But yeah, but this is actually a bad example. So you don't want to make sure, like, if a person makes a mistake and that mistake ends up to an error anyway, you don't want to write an assertion for it. If Python can already catch that error, then you don't want to write an assertion. So assertion is for things that do not result in a Python error, but you want to handle those situations. So if the person multiplies float by text, and anyway Python will not like that, so why would you write an assertion? It's not needed. So assertion is for handling those situations where your code will not break, but the output might be wrong. So yeah, you have different examples of assertions here that you can check later on your own, but they are useful. You can specify different conditions and make sure that you get the output that is reliable. So one last thing to look at for today is debugging your code. So we have been talking about errors, about assertions. One key thing to consider is, okay, how do you fix those errors? So how do you debug your code? Because very often we end up, the more complex your code is, the more likely it is that you have some bug somewhere, some error. So some general recommendations for debugging your code. When you write a code, test your code with known outputs. Remember, when I defined the function to convert Celsius to Fahrenheit, I tested it first with 0. Because I remembered that, okay, 0 degrees Celsius is 32 degrees Fahrenheit. If I tried it for some other number that I didn't know the right answer for, I wouldn't have known if it was correct or not. So when you write something, test it with some known outputs. Make sure your code crashes quickly and regularly. That might sound wrong, but that's a good thing. Because later on when you're working with real data sets, they can be very large. You might have a for loop that might take 2 hours to run. If you have a mistake, do you want to wait 2 hours to find out that, oh, I had a mistake in my code? Like after all the for loop, then you have a syntax error somewhere. So try it with smaller data and if there is an error, you want it to crash quickly so you can fix it, not that you wait for 2 hours to fix the error. But that can happen quite a lot. So make your code crash quickly and regularly, if that's what is going to happen. Not wait a day running some code to see that, okay, you had a typo somewhere. And make a small changes and track them. So when you make small changes, like for example, next week we will talk about your final project, and you will be working with something that is a bit longer. So make some changes, test the code. Because if you do a lot of changes, then you run the code, then it's hard to know, okay, which part caused the error. But if you add something small, you test it, and it breaks, you know, okay, what I just added was wrong. So that's one thing. Yeah, and of course we are using version control. So if you commit regularly, if you make something wrong, if something goes wrong, then you have a version of it on GitHub that you can revert to. So that's, with debugging also, GitHub can be quite useful. Yeah, so that was a bit of information about errors and how to handle them, how to read them, and how to handle them to end up with a bug-free code. And that was it for today. So we have exercise 6, which is actually your final exercise. Then we will have the final assignment. So you will be working with some coordinates, data frame, grouping, so similar things that we have talked about today. And then next week we will meet here again for the last time in this period, and we will talk about your final assignment. Do you have any questions from what we talked about today? If not, we can finish here and let's meet next week, same place, same time.